derivatives of more exponentials and logarithmic functions. So we're just going to continue on to develop more derivatives of different types of functions. The first one is review. So the derivative of the exponential function, the derivative of e to the x is again e to the x. And this is when I have a composition of functions. So the derivative of e to the g of x was, remember, g prime of x times e to the g of x. So the derivative of the outside function, we leave the inside the same, multiplied by the derivative of the inside function. So this first part's review, but now we want to go a little further and find the derivative for a general exponential function. So meaning that the base is a number other than e. So here, if I have the derivative with respect to x of b to the x, where b is some number greater than 0, then the derivative is the natural log of b times the exponential function b to the x. So here we have this restriction, b has to be positive because the derivative answer includes the natural log of that number b, and I can only take the natural log of a positive number. So here the formula tells me the derivative of a general exponential is the natural log of the base multiplied by the exponential. And we can, of course, apply the chain rule if there is a function inside of the exponent. So if we have the derivative of b to the g of x, then that would just be g prime of x times the natural log of b times b to the g of x. So it's the same idea with using the chain rule on a composition of functions like e to the g of x. The same rule applies. We leave the inside function the same. When we take the derivative of the outside would be b to the g of x times the natural log of b, and we multiply by the derivative of the inside, so times g prime of x. So it's just the chain rule applied to the general exponential function here. So let's go ahead and do some examples of this second type, since we've already seen quite a few of the first type. So here we go. Let's look at some examples. Here are the rules up here for us to help us remember. When we want to find the derivative of y equals 4 to the x, we need to recognize this as a general exponential function and then apply the rule for finding its derivative. So y prime here, the derivative, is going to be, well, we just repeat the exponential, so 4 to the x, and we multiply that by natural log of the base, so natural log of 4. So natural log of 4 times 4 to the x, that's it. I'm done. That's my derivative of y equals 4 to the x. Now the second one involves a chain rule here. So y prime in this case is going to be, so here we want to take the derivative of the outside function. So the outside function here is 4 to the x. Well, we just did that derivative, and what did we do? We had the natural log of 4, and then we had 4 to the x, but this time instead of x we have sine x inside. So we have the natural log of 4 times 4 to the sine x, and then we have to apply the chain rule and multiply by the derivative of sine, which is just cosine x. So here our derivative is going to be cosine x multiplied by the natural log of 4 times 4 to the power of sine x. So it just looks a little bit much, but we're really applying this general exponential rule and the chain rule all at the same time. So we just have to make sure, the only thing I will warn you of is to make sure that this sine of x really looks like it's in the exponent of the exponential function. The next two sets of derivatives we're going to review are the derivatives of the natural logarithm and of a general logarithm. So these are new for us. So let's take a look at the derivative of the natural log function. Well, the derivative of the natural log function is 1 over x when x is greater than 0. And we can think about that. We'll just draw a little quick picture of the natural log of x over here. So it looks something like this, and notice it's not defined, the natural log function is not defined for values that are negative or even 0, so we can only define it for values greater than 0, so that's why this restriction is here. And then again, we continue to explore what happens when we have a composition involving the natural log. So the natural log of now some other function g of x is going to be g prime of x divided by g of x. So we take the derivative of the outside. The derivative of the natural log says that we put what's on the inside on the bottom, and the chain rule says we have to multiply by what's on the inside, so that's where the g prime of x in the numerator is coming from. So we're going to see a lot of problems involving taking the derivative of the natural log and the natural log of another type of function. This one's a little bit more rare, the derivative of a general logarithm. The formula here says the derivative of log base b of x equals 1 over the natural log of b times x, for, of course, values greater than 0. And then we apply that chain rule to this general logarithm derivative. So we just have to add that g prime of x to the numerator, and instead of an x, we have a g of x. So here are my formulas for the derivative of the natural log and a general log, and then their corresponding chain rule counterparts. So now let's go ahead and do an example. Alright, so we want to find the derivative of y equals the natural log of sine x. And I really like this one. I think it's a really good one because it simplifies using a trigonometric identity. So what we want to do is find y prime, the derivative. And remember, the derivative of the natural log, because that's the outside function here, we're using a chain rule. The derivative of the natural log of x is 1 over x, but instead of x I have sine x here, so it would be 1 over sine x. So I'm going to put that sine x on the bottom. And I'm leaving the top empty for now because I have to multiply by the derivative of the inside, and the derivative of sine is cosine x. So my derivative here is cosine x divided by sine x, but cosine x divided by sine x is cotangent x. So this is kind of an interesting one, but it does demonstrate pretty well the rule for finding the derivative of a natural log of a composition of functions. So natural log of sine of x here, so we're applying that derivative of the natural log and the chain rule. And another example of the natural log with a composition of functions here. So the natural log of x squared plus 3, if we want its derivative, again, we are going to take the derivative of the outside. The derivative of natural log of x is 1 over x, so that's the same as putting what's on the inside on the bottom. So we write the denominator as x squared plus 3, and we put the derivative of the inside in the numerator. So the derivative of x squared plus 3 is just 2x. So once you start remembering the rules, the natural log of another function or a composition of functions involving natural log, these problems end up being pretty easy to get through.